Module 10. Reaction Rates and Chemical Equilibrium. Reaction rates and chemical equilibrium are critical concepts in the study of chemistry. In this chapter, we will explore varying reaction rates of various types of substances, the conditions necessary for a chemical reaction to occur, reversible and irreversible reactions, relevant chemical reactions, and changes to equilibrium. Kc. Kc is a measure of how far a chemical reaction goes to form products instead of reactants. It tells us the relative amounts of reactants and products present when the reaction reaches equilibrium. A high Kc means that the reaction mostly goes to form products, while a low Kc means that the reaction mostly goes to form reactants. In other words, a high Kc value indicates that the equilibrium lies to the right, favoring the products, while a low Kc value indicates that the equilibrium lies to the left, favoring the reactants. So if Kc is much less than 1, then the reaction COCl2G is COG plus Cl2G. At equilibrium would mean that the concentration of the reactant is much greater than the concentration of products. Reaction rates. Reaction rates refer to the speed at which a chemical reaction occurs. The rate of a chemical reaction is influenced by several factors, including temperature, concentration of reactants and products, surface area of reactants, and the presence of a catalyst. Heat of reaction. Heat of reaction, also known as enthalpy of reaction, is the change in heat energy that occurs when a chemical reaction takes place under constant pressure. It is the energy difference between reactants and products in the chemical reaction. The heat of reaction can be exothermic or endothermic depending on whether heat is released or absorbed during the reaction. Exothermic and endothermic reactions describe the release of absorption of energy during a chemical or physical change. Exothermic reactions release energy in the form of heat or light, while endothermic reactions absorb energy. In exothermic reactions, the reactants have higher potential energy than the products, so energy is released as the reaction proceeds, resulting in a decrease in the overall energy level of the system. In endothermic reactions, the opposite is true and energy is absorbed as the reaction proceeds, resulting in an increase in the overall energy level of the system. Conditions necessary for a chemical reaction to occur. For a chemical reaction to occur, several conditions must be met, including the presence of reactants and energy. The energy required for a chemical reaction to occur is known as activation energy. The activation energy can be provided through heat, light, or other forms of energy. Reversible and irreversible reactions. Reversible reactions are reactions that can proceed in both the forward and reverse directions, while irreversible reactions only proceed in the forward direction. The direction of a reaction depends on the conditions of the reaction, including temperature, pressure, and concentration of reactants and products. Relevant chemical reactions. Several chemical reactions are relevant to the study of reaction rates and chemical equilibrium, including acid-base reactions, redox reactions, and precipitation reactions. These reactions have different reaction rates and equilibrium constants depending on the reactants and conditions of the reaction. Equilibrium constant. An equilibrium constant is a value that tells us the relative concentrations of reactants and products at equilibrium for a reversible reaction. The strength of the binding is related to the equilibrium constant. The higher the binding strength, the greater the equilibrium constant. So carbon monoxide binding to hemoglobin 140 times more strongly than oxygen does tells us that the equilibrium constant for the binding of CO is greater than oxygen. An example of a compound that can be used as a catalyst for a chemical reaction is titanium dioxide, TiO2. In chemistry, titanium dioxide is commonly used as a white pigment due to its high refractive index and opacity. It is also used as a photocatalyst, which means it can catalyze chemical reactions using light energy. In toothpaste, titanium dioxide is added to give the paste a white color. It also acts as a mild abrasive, helping to remove surface stains from teeth. Additionally, it is used to improve the texture and consistency of toothpaste, helping it to stay fresh and stable. Titanium dioxide is also used in other chemical applications, such as in the production of ceramics, glass, and plastics. It is also used as a catalyst in the production of sulfuric acid, a critical industrial chemical. Chemical equilibrium. Chemical equilibrium is the state of a chemical reaction where the concentrations of the reactants and products do not change over time. At equilibrium, the forward and reverse reactions occur at equal rates, and the equilibrium constant represents the ratio of the concentrations of the products to the concentrations of the reactants. Changes to equilibrium. Changes to equilibrium can occur when the conditions of the reaction change, such as a change in temperature, pressure, or concentration of reactants or products. These changes can shift the equilibrium position, resulting in changes in the concentrations of the reactants and products. So, when a soft drink is left open, the drink eventually goes flat. This happens because the equilibrium between carbonic acid and carbon dioxide shifts to produce more carbon dioxide. Similarly, for the reaction 3H2G plus N2G to 2NH3G plus heat at equilibrium, if the temperature is raised, the amount of N2 will increase.